So for grade 10, we learned about factoring a few different ways. The key thing that we learned about is identifying the number of terms. So monomial is one term, binomial is two terms, trinomial is three terms. We also talked about degree, so the exponent that's present, whether it's x squared or your variable squared, not squared, or if there's no variable at all, it's a constant term. And then we talked about how to actually pull them apart and multiply them together. So this unit is going to focus mostly on the pulling apart and factoring of them. So that's what we're going to be reviewing today. If you do need a refresher on multiplying, just let me know, and I'd be more than happy to help you with that in class. Remember, FOIL for multiplying. So when we start to factor, the first thing that we need to do is take out our greatest common factors. We do this every time we're factoring anything, no matter how many terms it has, no matter what else we're going to have to do. Your first step is always to check for common factors between all the terms that are present. So starting with example A, we look at 2x squared and plus 4x. You can treat it as two separate pieces, the coefficients and your variables, and think about it that way, or look at it as a whole, whatever works better for you. I personally look at my coefficients, then my variables, just because I find that that helps me keep things separate but together. When I think about 2's and 4's, that's something that we've been doing for a long time. It comes very, very quickly. Variables might be a little bit more tricky, so you have time to think about it on its own. You're not throwing in extra complications. So for this example, we've got 2 and 4. Is there a common factor there? Absolutely. I'm going to switch to black here. Our common factor is 2. Now, if I divide both of these terms by 2, which is what factoring is, 2 divided by 2 is 1, and 4 divided by 2 is 2. So I'm going to fill that in to help me decide how that dividing out the 2, the factoring out 2, impacts my initial binomial. Then I look at my variables, and x is present in both terms, which means I can factor out x. In this case, I can only take about 1x because there's only 1x present in my second term. X squared divided by 1x, or if you think about it as multiplying, x squared is the same thing as x times x. So if we're taking 1 out of there, we are left with a single x. So remember, 2 divided by 2 is 1. Now we're left with only a single x, so it's going to be just that. We are left with no x's if we've taken out 1. So it's just going to be 2 left in our second term, and now I am finished. There's nothing else I can do. So that's my final answer for example A. Moving down, example B is a trinomial. Now in all trinomials, we like to think about it as ax squared plus bx plus c. That's our sort of general terminology for all trinomials that have a degree of 2. And we can kind of see how this one fits in there. This is an example of a trinomial where a equals 1. And we call this a simple trinomial. From here, before I do anything, I'm going to check for my greatest common factors. X is only present in 2 out of 3 terms, so I'm not going to be able to divide that out, factor it out. There's also no coefficient in front of my x squared. I said a is 1, which means even though negative 2 is common to both the second and third terms, for b and c, if I'm going by my general equation here, I cannot factor it out unless I want a fraction showing up in my first term. Like we all know, fractions are one of our F words in math. We're going to avoid them as much as possible. So how do we think about this? Well, I'm going to actually erase that equal sign. If we recall from last year, this value here is the product of our constants and our binomials. This guy here is the sum. Now this only works for simple trinomials. Once we get to complex trinomials, things get a little bit messy. So I'm looking for two numbers. Then when they multiply together, they give me -8. And when they add together, they give me -2. So you can guess and check. One of the methods I showed my grade 10s last year was I put my factors of my x squared term on the left, so x times x. Now I'm going to play around with numbers that give me -8, which are going to be -4 and 2 maybe. The reason I chose my larger term to be negative is when I'm going to add these together, I am left with a negative value, which means my larger number had to be the one giving me the negatives. From here, I can multiply across to check to see that I've done this right. X times -4 is -4x. X multiplied by 2 is 2x. When I add those together, it gives me -2x, which is my middle term. So if you don't remember what your strategy was from last year, you're more than welcome to use this. It's kind of in the same vein as any other strategy, but my final answer is going to be x minus 4 working across these pieces, or what's going to be in my brackets because they don't ever multiply by each other. And my second set of brackets is x plus 2. And so that's my factored version, 2 binomials. Now question C looks a little scarier because we've got an a value that isn't 1. So instead, the first thing I'm going to do is not change at all, not going to change at all. It's going to be see if I have a common factor. Now I check my variables. I've got t squared, t, and no variable at all, which means the variable is not common to all three terms. I'm not factoring it out. But -4 actually is a factor of all three constant pieces, our coefficients and our constant term. So I am going to divide that out to start. So step 1, always greatest common factor. So I'm going to divide -4 out of everything. -4 divided by -4 is 1, so I'm left with just t squared. -4 going into -16 is actually +4. And then -4 into +128, I'm going to have to double check. And that's going to be 32. Now that I've done that, what's left over in the brackets is a simple trinomial, something that we are a little bit more comfortable dealing with. So again, I'm going to crisscross. This is my product. This is my sum. And this is the product of my first two terms. So I've got t multiplied by t to give me t squared. I need two numbers that multiply to give me 32 with a difference of 4. So I think about the factor pairs of 32. If you need to make a list, you can. 1 and 32, 2 and 16, 4 and 8. And all of a sudden I see 2, which have a difference of 4. And I like that it's a difference of 4 because I need to be making -32. So one of those two pieces has to be negative. In this case, my middle term is positive, so the greater number should be positive because that's what's going to be left over. So I'm going to have +8 and -4. So if I want to check that this is going to work, I multiply across and across. T times 8 is 8t. T times -4 is -4t. And if I sum those, then I get positive 4t, which is my middle term. And so I know that that has worked out as well. So my final answer, applying this strategy, is -4. Again, going across, I've got t plus 8, t minus 4. Now, if this crisscross method is not something you've seen before, or you're like, you know what, I can just spot the factors, I don't need to do this, then don't do it. But make sure you have some strategy for making sure that you are in fact going to produce the correct middle and constant terms. And I will box off my answer so it's always easy to find. So sliding over here, we're looking at D. Again, we are in ax squared plus bx plus c mode, always decreasing our exponents. We've got a is not equal to 1. So it's a red flag. I want to check for greatest common factor for sure. Can 3 go into 13? No. So now, all of a sudden, instead of dealing with, like in the previous two, where I'm dealing with a simple trinomial, I am dealing with a scenario where a is not equal to 1. Therefore, I call this a complex trinomial. So our strategies for dealing with this can be a little different. Option 1 is guess and check, and now you're just going to have to vary the values out in front of your x terms as well. Another option is to kind of work systematically and applying basically an unfoiling of our trinomial. So I'm going to do the unfoiling. And we start by taking the product of our first and last values. So 3 multiplied by 10 gives me -30 because it's -10. And I need factor pairs that are going to add up to 13. So our gut instinct might be, well, like 3 and 10 add up to 13. But remember that we've got a -30. So these two values, our two factors in our factor pair, are going to have opposite signs. So 3 plus -10 is not going to equal -13. Neither is -3 plus +10. So we need to do some thinking. Now you might already have that answer and you can skip a little bit ahead. I'm going to break it down the long way. Okay, so those are all my possible factor pairs of -30. I haven't put a sign anywhere because I need to decide which one I'm dealing with. I'm probably going to put it on the larger one, since when we add them together, I'm left with a negative value. So our larger value accounts for that being left over. So when I look at these now, I see that instead of using 3 and 10, I'm going to use 2 and -15. So I'm going to break this guy apart now. And this piece is going to become 2 pieces. So we're left with, instead of -13, I'm going to have -15x plus 2x. But don't forget your other pieces of the puzzle. We haven't changed them. From here, we're trying to create that binomial sense. So we're going to imagine like these are 2 separate pieces. We look for a factor in our first 2. So 3 divides 15 and 3 evenly, so I'm going to factor that out. But I can also take an x out of both of those terms, so now I've got a different factor. We're left with x minus 5. Over here, 2x and negative 10, the only thing in common with them is positive 2. And what we're left with is x minus 5. Do you see anything? Absolutely. These two pieces that were left behind when we factored out the greatest common factor are the same. Now this is where it gets a little complicated. We can think of it as actually factoring those pieces out. So I take out x minus 5, and I'm taking that out of this whole term and this whole term. So taking it out there, what we're left with is we're left with 3x in this term and 2 here. And now I have done, I have completely factored this. That is my final answer. Seems kind of crazy. A whole lot of thinking involved. You can guess and check. It just sometimes will take you a long time. Moving on to E. We're going to use the same strategy. If you want to pause the video and try it on your own first, I think that would be an awesome idea. First thing I'm going to do, multiply these two. Actually, I'm going to do the guess and check method. So I'm going to guess and check, which means just off to the side. I'm not going to do it directly underneath. I need two factors of 4x squared. So I know I'm going to need an x in both. To start with, I'm going to go with 2 and 2. Now 9, on the other hand, I could go 9 and 1. Could try it out. If I multiply across, that gives me 18 and 1x. That is not going to equal 12. So instead, let's try some other factors of 9, 3, and 3. Now I'm choosing 2 with the same signs because anything multiplied positive, positive is a positive, negative, negative is a positive. A negative and a positive multiplied together, though, it gives us a negative. So we got to watch out for our integers now. That is a common place where people make mistakes and it can mess up your whole scenario. So you got to be super careful. Last unit I said you got to be super careful with integers. Now it's even more important. So 2 times 3 is 6x. 2 times 3, 6x. When we add those together, we get 12x, and what? That's our middle term. So now I've got this factored. Now, you might be saying, well, those are actually the same thing. So some people will go ahead and write it like this as two separate terms, two separate binomials, sorry. But that is not the simplest way to write it. How can we represent two of the exact same thing multiplying by itself? We square it. So that would be my final answer. That we call a perfect square trinomial. Finally, example F. We've got 81. If you don't recognize it right away, 81 is a perfect square. 49 is also a perfect square, and m squared is a perfect square. So already getting a red flag. In addition to that, unlike our previous 4 questions, this only has 2 terms. So the first thing we want to do is check for common factors, just like every other time. 81 and 49 do not have any common factors. So we're not going to be able to simplify it like we did in example A. But this is a special guy. It is called a difference of squares. And what happens when we have a difference of squares? It means it's going to look a lot like this one. We want almost the exact same terms, but we're missing that middle term. Sorry, I'll scroll down a little more. We're missing that 12x. The reason that happens is we have opposite signs in here. Instead of plus and plus, we've got one adding and one subtracting, and so they cancel each other out. It would have resulted in 6 subtract 6, which would give us 0 instead. Down here, similar effect. We've got the square root of 81 is 9. Square root of m squared is m. So that's going to be my first term in both binomials. Square root of 49 is 7. In order for them, when we add them together, to cancel out, one needs to be positive and one needs to be negative. So the difference of squares is really clutch that you just be able to identify it. So being familiar with perfect squares, understanding that any even exponent is actually a perfect square, and being able to recognize that subtracting, when we talk about it in math, can be talked about as a difference, will help you recognize this a little bit easier. So the next page in your booklet is a bunch of practice questions for factoring polynomials. They don't go beyond the grade 10 scope, so give them a shot, and then you'll be ready to move on to the next lesson.